is being recorded.
All right, so I'm just going to say welcome to everyone. It's fantastic to see you all here. We've got Kai, we've got Kerry, we've got Jacob, we've got Isaac, we've got lots of Isaacs. We've got Isaiah, we've got Maddie, we've got Max, we've got Oak. And then Kerry and I are happy to see you. Today, we are going to be looking at, we're going to be developing some multiplication and division strategies. I think a lot of you have a lot of these strategies already. We're going to talk about the commutative law and the associative law. They sound really complex, they're really not, and we're going to spend like probably a minute explaining it, so I won't take up too much of your time. And we're going to do order of operations. In the chat, can you let me know if you've done order of operations at school before? You might know it as BODMAS or PEDMAS, PIMDAS, BIDMAS. Kerry, can you think of any other ways you may have heard it?
No, BODMAS, BOMDAS, PEMDAS.
Yeah. What do we prefer, BOMDAS, PEDMAS? I'm
a BOMDAS girl, but
yeah, I think I'm with BODMAS.
Did I say that? Yeah, BODMAS.
Yeah, BODMAS. It's very 80s, very 90s, 80s. But I think they like PEDMAS now. But
that's very American, because we don't really use the word parentheses. In Australia, we tend to use brackets.
We do, don't we? Well, I call the square brackets parentheses. Am I getting that wrong?
I call them square brackets.
I call them square brackets too. But, all right. The success criteria is we know what the commutative and associative law is, so we can do the mathletics. It doesn't matter if you forget it, but we do need to cover it. We can develop some multiplication and addition strategies to do that. We can do some computations in our head, and we should be able to do some BODMAS. Okay. All right. So in the chat, multiplication, what are some different ways we can say 6 multiplied by 3? Different ways you could give them the answer. Yeah, brilliant. 6 times 3, awesome. 6 multiplied by 3, 6, 3.6. Oh, they've already got the associative rule. But yeah, we could say it as 3 times 6, brilliant. Or we could do 3 star. And we tend to do that in Excel when we're programming a spreadsheet. Kerry did 6 plus 6 plus 6. 6 equals 6 equals 6. I don't think that makes sense. 6 equals 6. Oh, if I had 6 oranges and someone gave me triple the amount I already have, I would have 18 divided by 3 equals 6. Oh, that's okay. Has anybody seen 3.6? Yes, no? Or 6.3? Has anybody seen that for multiplication, like a shorthand way? Nope. Yes. Nope. Well, that's another way we could write 3 multiplied by 6. I'll just put that with square brackets. And thanks, Kerry. We could also write it as 6 brackets 3. Or 3 brackets 6. Has anybody seen the bracket method as well? 9 squared. I'm not sure if 9 squared works. Wouldn't that be 81? No, 9 times 9 squared would be 9 multiplied by 9, and that gives us 81. We'll double check it on the next window. But yeah, please be aware of 3.6, or, because I use them quite a bit, of 6 bracket 3. So 6 bracket 3 is 6 multiplied by 3.
We just have to be careful with the dot. When I was teaching in America, they were quite indignant that I didn't really care where I put my dot for my decimals.
Yeah, true. So that's a really good point, Kerry. We usually see the dot for when we're looking at algebra, and it does look like a bit like a decimal to me
Yeah.
as well.
It's exactly like a decimal. And
No,
mm,
thanks for that pickup.
so you just got to understand in the context of the question, I suppose, what you're looking at. So yeah, dot can sometimes be confusing for the younger students, I think.
Yeah. So, but please use the brackets. They work very well. So 6 multiplied by 3 is 6 by 3. The other word that nobody brought up for timesing begins with P, R, O. Does anybody want to guess what it is? PRO. Who's not Carrie? Another word for multiplication.
Definitely the product.
Definitely. The product.
Yeah.
Oh, produce. No, not produce. It's
No.
product.
Mm. We
By the way, the
associate products with
supermarkets are full
sorry.
of produce at the moment, aren't they, Carrie?
They're what?
Full of produce.
No, I put up a picture on my Facebook yesterday of my local Aldi with no meat at all. None.
Yeah, no.
Zippo. But I
Lots of
went to my
produce
fruit
though.
shop and I got plenty of vegetables.
Lots of vegetables. And no toilet paper. Yeah. I should have chucked in a toilet paper question. Okay. Do we know how to use a multiplication grid? I'm going to go for it super quickly if you don't, but I just want, yes?
Often kids will have this on the back of a textbook. It usually probably goes to maybe 12 times 12 or maybe up to the 10 times 10.
I've got one in the course that goes up to 20. But if you are not amazing with your multiplication, Carrie and I recommend that you use it, especially at the moment.
Yeah, we don't want you to get hung up on them. You know, you're trying to solve a problem and the thing that's holding you back is being able to do your tables. So
Yeah.
use the grid and then you can use that to help you solve the problem.
Yeah. We do expect you though to, as a minimum, to know that you know how to do your 2s, 5s, and 10s. So to double and half, and multiply by 5 and 10. But I think you're all pretty good at that. So 7 times 6, just using the table, we'd look at the 7 column, and then we would try to find the 6th row, which we get to.
Would it be the same if I did the 7th row and the 6th column?
You could definitely do the 7th row and the well, there's 6th column in the 7th row.
Yeah.
There we go. 42.
Why?
Well, I do.
Multiplication. Don't tell everyone.
Does anybody want to do one on the screen for me? You can have access to the speaker. Yeah. In the chat. 13 times 11. Well, we've got the answer. Does anybody want to demonstrate it on the screen?
Well, somebody might be doing that. Does anybody know the trick when you're multiplying by 11?
Okay, so you can probably talk CPJN5. Just turn on your microphone.
That's Cooper.
It's Cooper.
Hello.
Cooper gets
Cooper.
a lot of feedback down there.
11 times 13, you'd have to look on the 2020 chart.
Cool. So what column are we looking for, Cooper?
The 13 and the 11.
So we're looking at the 13 column. Brilliant. And then we're finding 11, the 11th row, yeah? And what do we get?
You would get 143.
143. Brilliant. What did Bastian work? Yeah, so 11.
I think Bastian tried to answer my question because I asked, does anybody know the trick to multiplying by 11? And Bastian said to multiply by 10 and then add on another one, which is a good way to do it. But when you're multiplying by 11, I can tell you a little trick. If you look at the outside numbers, which is a 1 and 3, and you add them together and pop it on the inside, it works. So 1 plus 3 is 4. So pop the 4 in between the 1 and the 3, it becomes a 143. 11's
you want to do that on the screen, Carrie?
Oh, do I have drawing rights?
No, you don't, because I'm sharing the screen. Yeah, you can draw on the screen, I think. If you go to annotate,
I'm requesting to annotate.
Yeah, and I am approving.
Oh, good. Oh, thank you. So if I add it's going to be nice and thick. 1 plus 3 being the 4, and I pop that 4 in the middle there. It's a little trick. So we could try it. So if we had, I don't know, 15 times 11. So using this particular method, I'd add the two numbers together, get a 6, and pop it in the middle. Ta-da! 15 times 11 is 165. Why, thank you, Angus. I've got lots of little tricks like that.
Yeah, she's full of little tricks. I would have done it as 10 multiplied by 10. If I had to do it in my
like
head,
Baston
10.
said, yeah.
Yeah, 10 by 13, which would give us 130.
Hmm.
And then I would just add on a
Yeah, it's a nice
11
little
onto
trick.
that.
So in fact, if you look down your 11 times table, you know, here you can see 176 because that's 16 times 11, 17 times 11, there's your 1 and 7 and 8 in the middle, and so on. Really good for 2 digits and gets a little bit trickier after that, but that's for a whole nother day. I will tell you the tricks as I see them come up, Isaac.
She will, definitely. Okay, so we're going to move on. We won't do the division.
I'll try and erase my...
Oh, that's okay. I'll just turn off annotate.
Yeah. I don't know how to make it disappear. Oh, here.
There we go. Got it.
Got it.
Okay. So the first word that I'm going to use today, and it's important for Mathletics. Carrie and I actually forget this word quite often, but I understand the principle, and the principle isn't that difficult. For multiplication and division, it doesn't matter what numbers, it does matter what numbers we are multiplying, but it doesn't matter with the order, okay? So for addition, if we did 7 plus 3, that should equal 3 plus 7.
Could you just go back to the last slide, please, Jacob? Because I think you wrote division and when you meant addition.
I know.
Oh, sorry.
Did.
As long as,
That's why I was moving on quick.
Oh, no, I just want to, well, kids who come back and watch it later on. So it doesn't matter when we're, because I can see you've got adding and multiplying there, but it's just a typo sort of thing.
But anyway, the order doesn't matter. No. For multiplication and addition. So 7 plus 3, we're at 7 and we're adding 3. And what should we get to, guys, if we're counting? Yep, we should get to 10. And if we're at 3 and we're adding 7, so we're taking 7 steps, what should we get to? Yeah, we should get to 10. So the order doesn't matter for addition. Can I get a why? Who already knew this? Yep, I don't think we're that surprised. And it's the same for multiplication. So this is the commutative law. So we're just moving or commuting the numbers. It's the same for multiplication. So 13 multiplied by 11, guys. Looking at the chart, if we did found the 13th
use my trick. Use my trick.
If you want to explain your trick again, that'd be amazing.
Well, it was the same example that I did before. So 1 and 3 is 4. Whack it in the middle.
Yeah, 1 for 3. There we go. Yeah, you're right, and it definitely does work for subtraction and division.
Yeah.
So,
and you're right there, Isaac. It does matter for division. So here we go. Yeah.
All right, looking at subtraction. So would we get the same result? So 3 multiply 3 minus 5. Does that equal 5 take 3? Yes or no? You're right, it doesn't work. So if we start at 3 and we're taking 5 steps backwards, we'll get to, or 5 would get to -2. And if we start at 5 and we take 3 steps backwards, we should get to 2. So these two problems don't equal. So it doesn't work for subtraction. And if we go to division, okay, there we go. It won't work either. So if we have
get another typo in this one here.
Wow.
We have 6 things.
Ah,
Yeah.
yeah, thank you. All right, so 3 divided by 6. So we have to divide these 3 little circles into 6 parts. So we'll get a fraction, which would be 1/2. And for the next one, we have 3 things, and we need to divide it into. We have 6 things, and we need to divide it into 3 parts. We have groups of 2. So it does not work for subtraction or division. Okay.
What
The
did you?
next-
Sorry, just as I just want to clear up that he said this one works.
Doesn't work.
They don't work. Order is important for dividing and subtracting.
Yeah, so very good. Order, and I'll put that on the screen. Thanks, Kerry. Order is important for division and subtraction, but not for multiplication and division. Multiplication and addition. Right.
What,
The next
mm,
rule that we need to talk about just for the Mathletics is the associative law. The word associative comes from the word associate or to group. So the picture I have is of soccer players. I think one's Liverpool. I don't know what the top one is. FCB. But Barcelona. Thank you. But these are all soccer players. They're just in different groups. The associative law. We group things in math using brackets. Has anybody used brackets here before in the chat? Yes, no? Ornella, have you used brackets? Awesome. Yep. So the associative law is we're putting in brackets. It doesn't matter for multiplication and addition where we put the brackets. So remember when we do brackets, we do the brackets first. If we're solving this side, 2 plus 4, what does that give us, guys? 6. And we'll rewrite it plus 3. And the next one, 2 plus 4 plus 3, what does that give us, guys? 7. All right, 6 plus 3, guys. 9, brilliant. And 2 plus 7. So for addition, where we put the brackets doesn't matter. I skip that one. And for multiplication, also doesn't matter. So looking at the first one, we always do the brackets first. 2 by 4, what do we get? We get 8. We have to multiply that by 3, and we'll do the second half of the problem. 2 by 4 by 3. So what's 4 by 3, guys? 12. Awesome. Now I'm going to test you. 8 multiplied by 3, what does that give us, guys? If you don't know, please use the grid. It's 24. And 2 by 12, guys? 24. Brilliant. We're going for time. Almost done. Okay, so we're going to do a little bit of a quiz. And this is from your Mathletics, so you will be doing this in Mathletics. So after this lesson, if you want to jump on Mathletics and do the first lesson of Module B, and if you know what we're doing at the moment, you should be fine. Which property of addition does the number sentence show? The commutative or the associative, guys? So which one had the brackets? Was it the associative one or the commutative one? I will double check. The associative one had brackets, the commutative one didn't. So it will be associative because there's no brackets. That's okay. And we could probably solve it. 7 plus 6, what does that give us? 13, brilliant. And what would the missing number be? The second one, it'd be 6, because it doesn't matter what order we're putting the addition in. So 7 plus 6 is equal to 6 plus 7. All right, what about this one? Does this have brackets, guys? Yes or no? Yes. So if it has brackets, which one would it be? No, not commutative, because commutative just means we're rearranging. So I'll put that on the screen. And associative means we're grouping. Okay, so it'll be associative. All right. What would this missing number be? 7 plus something plus 9. Because we want both equations to equal. Oh, all right, we'll look at this side. What is 7 plus 6? Yeah, it'll definitely be 6. So 7 plus 6 is 13, because we've done the brackets first. Plus 9, what do we get, guys? 13 plus 9, we'll get 22. Brilliant. And looking at this side, I'm going to change my color. I'll do a nice blue. We're doing the brackets first. So 7 plus 6 plus 9. What is 6 plus 9, guys? 15. And so 7 plus 15, what does that give us? 22. Brilliant. So our answer is 22. Okay. Looking at this question, does it have brackets? Yes or no? In the chat. No. So if it doesn't have brackets and we're just rearranging the numbers, would it be associative or commutative? Yeah, it'll be commutative. Brilliant. Because commutative just means we're rearranging. What is the missing number? 2. Brilliant. And 2 times 9 gives us what, guys? 18. Awesome. All right. Next one. Commutative or associative? In the chat. So we've got a couple of commutatives down. Why did we say commutatives? You're all correct, by the way. No brackets, brilliant. And we're just, rearranging the numbers. So 1 plus 8 equals 9. And in the blank spot, we've got 8. For time. All right, I think this is the last one. Commutative or associative, guys? So we've got one answer, which was associative. You can just put an A. Awesome, you're right. It is definitely associative because we're just moving around the brackets. So, and we'll just solve it right now. 2 times 3 gives us what? That's okay. Isaac, if it's got brackets, it's associative. If it doesn't, commutative. All right. 2 multiplied by 3. We've got lots of 5s. We're doing timesing. Yep. So we've got 6 multiplied by 1 on this side. And what do you reckon that missing space is on the second side? Guys? Brilliant. It's a 3. Remember, we do the what's in the brackets first. So 3 multiplied by 1 gives us 3. Which 2 multiplied by 3 gives us 6. So our answer should be 6. All right, we'll skip that. Okay, so what can you do from the module B? You can start with week 1, lesson 1, and you can do the revision as long as you've got the grid. For time, 5 more minutes. Okay, these rules are really useful because we use them to solve problems such as this one. So 7 plus 32 plus 13. If there are 2 numbers in that problem that you would add first, which ones would it be? And why? So Cooper said 20. Yep, 7 and 13, because it'll give us a multiple of 10. So we'll just group them together. That gives us 20.
Isaiah says 32 and 13, which is an interesting combination too.
Yeah, I could.
I don't understand why, because they're bigger. I didn't understand that comment though.
Because they're bigger. Maybe bigger numbers are frightening. Okay, so so 7 plus 13 gives us 20. And then we've got 20 plus 32. What do we get, guys?
Yeah, the whole idea though, Isaac, here is to put numbers together to make it easier. So what Jacob's done is realise that 7 and 3 make it 10. And so 7 and 13 will make 20, and 20 is easier to add. So if you had have done 32 plus 13, you would certainly have come up with 45, and 45 plus 7 is 52. So working with tens and fives is probably easier than if I had have done 7 plus 32 is 39, and then have to add a 13. So that's the strategy that we're talking about here.
Yeah, and it's just a strategy to make things easier because it's easier to work with 5s and 10s.
Yeah.
Like, who finds that in the chat? All right, we'll do another one, okay? 25 plus 91 plus 75. I want you to all have a go without a calculator. We'll give you about 30 seconds. Yeah, 30 seconds. Awesome. Okay, so in the chat, guys, thank you heaps for having a go. What did we add first? I think Esther put something down. 75 and 25. Yeah, so we grouped up the 25 and the 75. And that gave us 100, which is easier to work with than 25 plus 91. Sorry, 91, my bad. So 100 plus 91 gives us 191. Is that the same question? Yeah. All right, looking at the second one. 83 plus 52 plus 18. Which are the easier numbers to add? Oh, no, have it go first. So think about it, and then I'll start talking. And like I said, I'll give you 30 seconds.
Okay, it looks like everybody's on the right.
It does. Just one thing that I picked up, and I'm sorry to single you out, Esther, but a lot of students do it. 18 doesn't equal 70. You just have to be really careful because to me that doesn't work.
Well, 52 plus and 18, I can see where she's getting 70 from, but certainly saying 70 equals 153. So it's important that when you use your equal sign, I treat them very seriously. If you're going to tell me something's equal, then it needs to be equal.
And it's something that I make a mistake in as well occasionally. So what did we add first? We added 52 and 18. We'll grab that.
No, not the 83.
Sorry
Still
about
got
that.
the 83.
We'll change my color. Color, do red. Go back to red. So we'll do 52 plus 18. There are lots of other ways you could do it. I think I would have done 18 plus 83. Actually, no, I wouldn't. 52 plus 18. What did we get, guys?
Yeah, Isaac, I don't know.
We have to go. Look at the chat.
That's okay. We're
Okay, thanks,
just almost
guys.
done in a minute. So 52 plus 18.
Yeah, too much echo down there. You need to type it. Thank you.
All right, so 70 plus 83. That's okay.
Okay, school photos. Smile.
Yeah, have fun. Send Carrie your photo. Right, so 70 plus 83, guys, before we go, because we're just at the end.
And 7 and 8 is 15. So 153.
153. So using this these mental strategies, we're indirectly applying the associative and commutative rules. And we're at the end of the lesson, guys. Thank you. I'm sorry that I didn't get up to PEDMAFs and BOMDAS, but you've been fantastic. Thanks heaps for your contribution. Carrie, was there anything that you wanted to say?
No, just a reminder that I will be looking at, I was going to start geometry, like you were going to start geometry this week. So
we're going to start, we'll be doing
tomorrow.
some geometry on Wednesday. So we'll do some protractor stuff.
But yeah, come along on Tuesdays and Fridays at the same time if you want a little bit slower pace and a little bit extra help.
Yes. And Carrie's lessons are amazing, and they'll be on Tuesday and Friday at the same time at the same link. All right, guys. Thank you heaps for your efforts. And
actually, while I still have people here, just a reminder: some people are still having trouble uploading, and I know Jacob's put up a video on where to find the submission documents and how to put them up. So if you can have a look at that. Some of you are still trying to do everything on the computer, and you might need to print it out and scan it and send it back to us, please. And just be aware that it can take us a while to get our marking back to you, so we don't want you working too far ahead in case we've got some hints for you before you start doing your project. Okay.
Yeah, and by the way, guys, I'm totally looking forward to your projects. I've got a couple already, and I was super impressed. All right, bye, guys.
Thanks for the lesson, Jacob. Bye-bye.
You're welcome.